Hey students, this is lesson 7.2C, the last of the video lessons in unit 7.2. And this one we're going to learn how to represent inequalities graphically when they have two variables. So first of all, let's talk about what is a solution to a linear inequality with two variables. And they can be represented by ordered pairs. So looking at this ordered pair right here, we know that x is equal to -5 and y is equal to 2 in that one. And we want to know if it's a solution to this. So what I'm going to do is replace the x with -5 and the y with 2 and just see if it's true. If it's true, it's a solution. So is 2 less than -5 plus 2? Well, -5 plus 2 is -3, and 2 is not less than -3. So if you get a false statement, then you're going to say, no, it's not a solution. All right, let's try the ordered pair B. And that one, x is 4 and y is 6. So substituting in 4 for x and 6 for y into the inequality, we get 6 is less than 4 plus 2. So 6 is less than 6, and 6 is not less than 6, so again, it's false. If it said less than or equal to in our equality, then it's true, but it's false, so that answer is no also. All right, you try one of those. The next thing we're going to do is graph. Because when you have an inequality with two variables, there's many solutions. And basically, any ordered pair that makes this true is a solution. Well, there's a boundary line for this, and we need to introduce a new type of line here. If we have a less than or greater than, we're going to use a dotted line to represent that. So what that's saying is numbers right on the line are not solutions. If we have less than or equal to or greater than or equal to, we're going to use a solid line. So dotted line for less than or greater than, solid line for less than or equal to or greater than or equal to. So the first thing we want to do is just think about this equation, the related equation to this, which is y equals x minus 1. That's going to be the boundary line. Since our sign is less than, we're going to make a dotted boundary line. And we're just going to graph that, knowing what we know about that this is in slope-intercept form. Our slope is 1 because it's 1 times x, and our y-intercept is -1. All right, so we're going to put a point at the y-intercept, and then a slope of 1 means I'm going up 1 for every 1 I go over. So that'd be dots along this line. And then to graph that boundary line, we're going to use a dotted line. Okay. Now what I'm going to do is check a point on one side of the line. If that point is true, that's going to mean that all points on that side are true. I'm going to try this point right here, 0, 0, to see if it's true for this inequality. So what I'm saying is if I put 0 for y and 0 for x, will that be true? Is 0 less than 0 minus 1, which is -1? 0 is not less than -1, so that's false. And what that tells me is that points over here on this side are all going to not be solutions because 0, 0 wasn't a solution. So the points that are a solution are on the other side of the line. And actually, as we go here, when things are written in slope-intercept form, you'll notice that less than are shaded below the line and greater than will be shaded above the line, which kind of makes sense. So color in below that dotted line, or less than. All right, go ahead, you try it with this one, see if you can get it. All right, so you should notice that, again, we had a less than problem here, less than or equal to, and we ended up shading below the line. That'll be true when the inequality is written in slope-intercept form. All right. So sometimes we'll have an inequality with one variable, and what we'll have to think about here again is what does the boundary line look like? So So think about x equal to 2. What does that look like? So any point where the x coordinate has a 2, and that would actually be along this line right here. Since it's less than 2, we want to use a dotted line to graph that, like this. And then less than 2 would be numbers like when x is 1, which is right here, when x is 0, and so on. So we're going to shade to the left of that. And so anything over here will be in this graph's solution set. All right, and then on the other one, we have y equals greater than or equal to 3. So think about the boundary line again, it's y is equal to 3. So any point where y is equal to 3, that would be along this line right here. So all these. Now, since it can be greater than or equal to, we're going to use a solid line in this case. So I'm going to draw a solid line right along there. And we want numbers that where y is greater than or equal to 3. That'd be like up here where y is 4 and y is 5, all up there. So I'm going to shade it all up there this time. And so our graph will be shaded above that line. All right, you go ahead and try that. All right, so suppose you could spend no more than $20 for hot dogs and hamburgers for a picnic. Hot dogs cost $5 per package and hamburgers cost $8 per package. What are 3 possible combinations of packages of hamburgers and hot dogs that you could buy? Well, just to help you see this, I'm going to create a graph to help you see this. But if we let x equal the number of packages of hot dogs we buy, and 5 times x equals how much they cost. And then if we let y equal the number of packages of hamburgers we buy, well, we have $20 to spend, so the amount we spend on hamburgers and hot dogs has to be less than 20. So I'm going to create a graph for this. All right, so here's my graph. And so since this is written in standard form, let's use the intercepts to help us make the graph. The x-intercept would be 20 divided by 5, which is 4, and the y-intercept would be 20 divided by 8, which is 2.5. So if I graph those 2 points, x equals 4, that would be right here, and y equals 2.5, that would be right here. If I draw a line in there, and I'm not going to go beyond 0 because it wouldn't make sense to have 0 hot dog buns packages or 0 hamburger bun packages. And 0, 0 is a possibility because if I buy 0 of each, I would definitely be spending less than 20. So that means my shading is going to be in here. All right, and so I need 3 possibilities here of hamburger and hot dog buns. And so anything in that shaded area is a possibility, like right here. And X is my hot dog bun, so that means I could have 2 of those and 1 of the hamburger buns. That's a possibility. And I could also have 1 of each. That's a possibility. That's in there. I could have 0 hot dog buns and 2 hamburger buns. So any of those are possibilities. All right, you go ahead and try that on the next problem. So here's your answers for that. Now remember that your pounds of peanuts and pounds of cashews could actually be half numbers. So there are a bunch of other possibilities. They can be a fraction of a pound. You don't have to buy exactly a whole pound. All right, so think about that, and we will talk about this some more next time we meet.